Hello everyone, welcome to Engineering Xplained channel. In this session, I am going to take Basic Thermodynamics Model 1, Lecture 7. In that, I will take the PdV work or a displacement work. In the previous session, I have discussed about the work, its definition according to mechanics and according to thermodynamics. I also discussed. And in the deeper thermodynamic processes, where the pressure and volume changes, due to that, the work done we have to calculate, and how that pdv work is calculated generally will take for the one of the process, and later that equation can be used for the different thermodynamic processes. Kindly subscribe Engineering Explained channel. If you have subscribed already, kindly share and comment. Consider a system which contains a cylinder filled with a gas and a piston moving in frictionless cylinder as shown in figure. Okay, here this we are going to consider as a system. Here it consists of a gas inside the cylinder and piston which is moving frictionless within the cylinder due to the pressure of the gas. Let the piston move outward. Okay, here the piston is moving outward through a small distance dx. A small distance dx it is moving. The distance what it is moved. Okay, there that distance we are going to take as a dx. And later if we multiply with the area we are going to get the dv as the total volume change during that process in a time interval dt. Since the piston moves only a small distance, the pressure acting on the face of the piston can be assumed constant. For this only small distance the piston is moving, the pressure acting we are going to consider as a constant, not a variable process. Variable pressure. The infinitesimal small amount work done by the system is dw is equal to force multiplied with the distance it is a, according to definition of the work. Then the force what it is there, okay, where actually the pressure of the gas is acting, then the force is given by the pressure is force per area, then the force is equal to pressure into area, the area of the piston. Okay, the force will be pressure into area of the piston. Then distance moved by the pistons, that is the displacement. This can be written as pressure P, area of the piston A, and dx is a small distance of the piston moved. Then this area and this dx small distance, what the moves, there is a volume moved. The change in the volume we are going to take, the small change in the volume we are going to take as a dv. Okay, the area and the distance, the volume. This is the dv volume, the volume change during that moment we are going to take. A into dx is equal to dv. Therefore, the dw can be given as P into dv, the pressure multiplied with the volume change, and that is called as a PdV work or a displacement work. If you apply for the particular process, then if the piston is moving through a finite distance, okay, that small distance we have taken here, the finite distance, if the piston is moving, the work done by the piston is obtained by integrating the above equation between the initial and final state. Thus we get W1 to 2 is equal to integration of 1 to 2 dw or delta w, and that is equal to integration of 1 to 2 pdv, and this is the actual work for the change of the state of the particular the process. Then if the process proceeds from 2 to 1, the state 2 to state 1, we can write w2 to 1 is equal to integration of 2 to 1 delta w or dw, and that is 2 to 1 p into dv. Okay, this is the work done during the return process. Then this equation is applicable. This equation what is there? Okay, w1 to 2 is equal to integration of 1 to 2 pdv. This equation applicable for reversible, frictionless or quasi-static process. There are number of quasi-static processes which are studied in the thermodynamics. For that it will be applicable, and that system is a closed system. and there later we are going to discuss those quasi-static processes. Okay, there it may be a constant pressure process, constant volume process, or it may be an isothermal process, adiabatic process, or a polytropic process. For all those, the work done equation can be derived by taking this equation. Okay, later that we are going to discuss. And effect due to viscous force, magnetic force, gravitational force, and electric force are negligible. Okay, the viscosity of the gas, whatever is there, that is negligible. Magnetic force also we are going to neglect. Gravitational force also we will neglect that one. Electric force, all these force the additional are negligible in this one. Okay, by neglecting those, the work done equation we are going to determine. This is about the PdV work or a displacement work, where the pressure and the change in volume, due to that what work done we are going to have, that equation we have uh, taken, and that equation we are going to apply for the different processes. Thanks for watching. If you like, share, subscribe and comment.